Hey guys, it's Mrs. Jensko here. We're going to talk a little bit today about valence electrons. So let's get going with this and finish this up pretty quickly here. Valence electrons, they are electrons that are in the outermost energy level right here, outermost energy level of the atom. So on our Bohr's model, they are the electrons in the last circle, okay? The reason why they are so important is that they determine the chemical properties of that atom, because those are the ones that are involved in bonding, okay? Atomic number is the number of protons in the nucleus, which we've kind of already covered already. It determines what element you have. So for example, carbon has 6 protons because it is atomic number 6 on the periodic table. Nitrogen has 7 protons, it's atomic number 7. Oxygen has 8, it's atomic number 8, and so on and so on, okay? Each element has different properties, even though it only has one more or one less proton. That one teeny tiny little proton makes all the difference in the world. It makes it completely different element, and it just changes everything. That one teeny little proton. Okay. The number of protons and electrons, protons and electrons are equal in a neutral atom. It's when you have an odd number of protons and electrons that you get the charges to occur, okay? Lewis dot structures are a way of showing the number of valence electrons in an atom, okay? Again, valence electrons are the ones that are in the outermost energy level. So they show how things are going to bond, since those are the ones that are most important. Instead of having to show every single electron, since the ones that are in the outermost ones are the most important ones, Lewis dot structures are a way of just showing those most important ones, okay, since those are the ones that'll show you how they bond with another one. So what you do for Lewis dot structures is you write the elemental symbol, okay? You determine how many valence electrons you have, and then you put dots around it, and you only pair when necessary. So let me show you how you do this, okay? So we've got carbon. So the first thing you do is you write the elemental symbol, okay? So carbon is a letter C, a big letter C. All right, go to the periodic table. Carbon, right here, okay? I'm going to draw the Bohr model of carbon here first, okay? So it is, I've got my first, so I'm just going to draw it up here. I've got 6 protons, 6 neutrons. First energy level has 2, and then the last energy level has 4 dots to it, okay? This energy level, these dots right here are the most important, those 4 dots, okay? So what we're going to do is we're simply, since those dots that are in the last outer energy level are the most important, we just simply put 4 dots around it. And that's it. Ta-da, you're done, okay? Now, you only pair when necessary. So, for example, if you were to put 2 dots and 2 dots together like that, that is incorrect. You have to go on all 4 compass directions first before you start to pair when necessary, okay? Now, let's just say, for example, you have helium, okay? You have 2 dots, okay, and they go on side by side. Now, again, if you were to pair it up here, that's wrong. You have to put it on you have to put them on 2 different sides for it to be correct. But you could put those 2 dots, one on top, one on bottom. You could put one on left top and one on the left, one on the right, one on the top, one on the left. As long as they're not two together, you can put them on any side that you want. You just can't put two together. They have to be on the separate side. I like to just go on all four compass directions before I start to pair. Okay. Chlorine. Let's take a look at chlorine here. Okay. Chlorine over here is in the third and the third energy level. So the third one is the valence electron, because that's the last one. And it's going to have 7 dots to it: sodium, magnesium, aluminum, silicon, phosphorus, sulfur, and then chlorine. So it's going to have 7 dots to it. Okay. So chlorine has 1, 2, 3, 4. So I went on all 4 compass directions. Now I can start to pair it up. 5, 6, 7. And there you go. So you do pair when necessary. Okay. Now the big thing that I want you to make sure that you make note of, and I'll triple star this, okay, is you will never have more than 8 dots. Doesn't matter what element you are working on the periodic table, you will never have more than 8 dots. So if you start finding yourself drawing like 30 dots on an element, you got it wrong. Okay. You never have more than 8 dots on an element. Okay. Now there's an easy way to figure out how many valence electrons you are going to have on your Lewis dot structure, okay? And it's on the periodic table, and it's super easy, okay? So what it is, this very first row here has 1 valence electron. I'm just going to put VE to the minus, standing for valence electron, okay? Then we have 2 valence electrons. We are going to skip the middle section. We'll save that for when you're juniors and seniors and you take chemistry 1. We'll address that there at that point. Okay. Then you move back over here and we have 3 valence electrons, and I bet you can guess the next one. 4 valence electrons, 5, 6, 7, and lastly 8. So all have 1 valence electron, 2, 3, 4, 5, 6, 7, 8. Pretty easy. And that's it. That is valence electrons. So we'll have one more video on isotopes, and then we will be done with week 2 videos. So good luck. Have fun drawing dots with valence electrons.